Okay, is my presentation visible?
Yes, sir.
Yes, sir.
Yes, sir.
Mag-comment kayo ha pagka wala kasi ako ay nasa ibang tab. Okay, sheet metal and introduction. So as you can see in the pictures, those are the several types of metals that can be usually found on our community. So we have the cast iron, we have the wrought iron, aluminum, steel, carbon steel, brass, zinc, and copper. So those
Sir,
are
hindi pa po nag-slide.
Hindi pa ako nag-slide.
okay. Is the presentation visible?
Yes, sir.
Okay po. Pakisabi pagka hindi lumipat ha. Okay, lumipat.
Hindi pa
Hindi
po.
po.
Hindi po, sir.
Okay, ayaw na naman.
Yan, sir.
Yeah.
Ayan. So, kailangan palabas-labas. As you can see in the picture, those are several examples of metals that can be found in our community. So, we have cast iron, wrought iron, aluminum, steel, copper, zinc, brass, and carbon steel. Okay po, lumipat po.
Hindi po.
sir.
Yes,
Hindi
sir.
naman. Okay?
Yeah, okay po, sir.
Okay, so when we say metal, those are any of class of substances characterized by high electrical and thermal conductivity. Since our topic is sheet metal, so the main word which is the metal, so pag sinabi nating metal, it is characterized by high electrical and thermal conductivity. So ibig sabihin, metals are good conductor of electricity due to its characteristics like malleability, ductility, and high reflectivity of light. Ano? May nag-chat? Ano yung chat? Hindi ko mababasa. Anong sabi?
Present daw po si Andre Baculo, sir.
Okay, sige, mamaya. Okay po, next. Naglipat?
Hindi po, sir.
Hindi na naman. Ayan po.
Ayos na, sir.
Okay, so when we say metal, according to statistics, approximately there are 3/4 of all known chemical elements which are metal. So yung mga alam nating elements, ang 1/3 ang 3/4 or 3/4 doon ay metals. Ano? So the most abundant varieties in the Earth's crust are aluminum, iron, calcium, sodium, potassium, and magnesium. So the vast majority of metals are found in ores, which is the mineral-bearing substances. But a few such as copper, gold, platinum, and silver frequently occur in the free state because they do not readily react with other elements. So yan yung metals. So napaka-common naman ng metals. So bakit siya abundant? Kasi kumbaga siya ay ores galing sa mga bato. Kaya pagka madali siyang gawin. Siguro ang isa sa mga siguro ang isa sa uri ng metal which is not react with the other elements, yun yung mga copper, gold, and platinum. Okay po, naglilipat ba? Hindi.
Naglipat po.
Yeah. So metals are usually crystalline solids. So pag sinabi natin crystalline solid, edi matigas. Ano? So in most cases, they have a relatively simple crystal structure distinguished by a close packing of atoms and a high degree of symmetry. Typically, the atoms of metals contains less than half the full complement of electrons in their outermost shell. Because of these characteristics, metals tend not to form compound with each other. So, hindi na naman sisigurado yan lipat. So, another characteristics ng metal, they do however combine more readily with non-metals, which is oxygen and sulfur. Kaya siya kinakalawang. Ano? Which generally have more than half the maximum number of valence electrons. Metals differ widely in their chemical reactivity. So the most reactive include lithium, potassium, radium, whereas those of low reactivity are gold, silver, palladium, and platinum. So may mga bakal na reactant o reactive. Meron namang bakal na non-reactive. Ano? So pag sinabi nating reactive, whatever na ihalo o whatever elements na mapasama sa kanya, nagkakaroon siya ng physical and chemical changes. Not unlike dito sa mga low reactivity metals kagaya ng gold, silver, palladium, hindi siya basta nagre-react with other elements, or if not no reactions kagaya ng mga gold, hindi siya kinakalawang, pero nagkakaroon din siya ng konting mga amag-amag. So sa konting punas, konting linis, natatanggal. Okay po, nakuha po yung sa metal.
Yes, sir.
So far, madali lang naman siya. Next, lumipat, hindi.
Hindi po.
Hindi po.
Talagang kailangan ilabas bago saka i-play. Okay? Yan. Yan po, naglipat na po. Okay, the mechanical properties of metals such as hardness. Okay. So, pag sinabing hardness, ito yung tigas, tension, yung strength ng materials. Okay, it is the ability to resist repeated stressing, which is called fatigue strength. And then meron din tayong tinatawag na ductility and malleability, which are often attributed to defects and imperfections in their crystal structure. So pag sinabi natin ductility, wait lang. Ano ibig sabihin natin pag sinabing ductility? Anyone?
Sir,
Yes.
parang dinadalo yung po ng kuryente.
Okay. So when we say ductility, it refers to the ability of material to sustain significant plastic deformation before fracture. And then pag sinabi naman natin plastic deformation, it is the permanent distortion of material under applied stress, as opposed to elastic deformation, which is reversible upon removing stress. So ductility is a critical mechanical performance indicator, particularly in application that requires materials to bend, stretch, or deform in other ways without breaking. Meaning to say, ang bakal ay may kakayanan, ay may characteristics na madaling ma-bend, madaling ma-stretch, or ma-deform na hindi na sisira. Yun ang ductility. Okay pa? Nakuha ang ductility?
Yes, sir.
Okay. So, when we say naman malleability, ano ibig sabihin ng malleability? Sino may idea? Okay, it is same with the ductility. When we say malleability is the quality of something that can be shaped into something else without breaking, like the malleability of clay. So malleability also called plasticity. Okay, it has to do with whether something can be molded. So ibig sabihin ductility and malleability para siyang synonym to each other. Okay po? Okay. May question with between ductility and malleability?
Not, sir.
Wala po.
So that's why ductility and malleability often come with pair. Ano? So ibig sabihin yung ductility, the ability of materials to shape without changing its attributes, okay? Without breaking. So the absence of a layer of atoms in its densely packed structure, for example, enables a metal to deform plastically and prevents it from being brittle. Okay? Naglipat pa. So that is the metal.
Yes, sir.
Okay, ang sunod naman tinatawag nating sheet. Kasi kanina metal, ngayon sheet. So pag sinabing sheet, parang sa Tagalog piraso, tama ba? So a sheet is a large, wide amount of something flat, like a sheet of metal or a sheet of paper. So when it goes on your bed, a sheet is a similar expanse of fabric. Okay po? Talagang kailangan ilabas bago sa slide. Ano? Okay, so as you can see in the picture, that is an example of a sheet metal. Okay? So when we say sheet metal, is the presentation visible?
Yes,
Yes,
sir.
po.
Yes, sir.
So when we say sheet metal, it is a
Yes, sir.
metal formed into thin or flat pieces. So ito yung mga maninipis. Kumbaga sa Tagalog, yung mga yero, lata, ano. So usually by industrial process, sheet metal is one of the fundamental forms used in metal working. Okay. So the characteristics of a sheet metal, so syempre alam naman natin na manipis, ano, at the same time lightweight. So kung manipis, magaan, so syempre they are good in terms of production and in terms of industrial applications. So marami tayong industrial applications for sheet metal. Sino makakapagbigay ng halimbawa? Anyone? Kasi hindi ko kayo nakikita. Anyone?
Ano po yun,
Sir,
sir?
ano pong tanong?
Sabi ko, sheet metal is very good materials in terms of industrial applications. So, can you give examples kung saan ginagamit ang mga sheet metal? Yes. Hindi ko kayo nakikita. Exit lang. Yes.
Sir.
RJX. Yes, RJX. Walang na, hindi na si RJX.
Sir, ako po.
Wala kang audio. Si ano
Sir,
na
ako
lang?
po.
Oh, sige, Ellen May.
Ano po? Ang sheet metal po ay pagputol at pupuluktot. Ang sheet metal po.
Okay, applications ang ginagamit. Ang tanong ko kayo talaga.
Sir, ako po.
Sige,
Ako po.
Kian.
Sa ano, sir? Sidecar ng tricycle.
Okay, sa tricycle, pwede. Sa body. Saan pa? Sabi ni
Sir,
RJX
ako
sa
po.
construction.
Sa bubong, sir. Sa bubong.
Okay, sa bubong. Sige, isa-isa tayo. Si Earl.
Sa mga stainless, sir.
Okay, sa stainless. Okay, sige, magtawag ako dito para magka-recitation kayo. Aranas Giancarlo. Lahat nataas eh.
Sa mga building po, sir.
Okay, building. Okay, sige. Saan pa? Specific dapat para mas acceptable.
Sir, ka.
Yes, Ansa RJX. Wala.
Sir, ako, sir.
Hindi ko marinig si RJX. May niyang audio. Next, we have Alcaraz. Ronan.
Sir, sa body po ng sasakyan.
Okay, tama. Sa body ng sasakyan. Next, Araspe Ralph Ariel. Saan pa
Sir,
ginagamit?
sa ano po? Sa bubong po.
Okay, sa bubong. Tama. Okay, next we have Antonio Justin.
Sa ano sir, sa mga building sir.
Okay, building. Sige, next we have Frane Ralph Daniel.
Yun po sa mga dilata po.
Dilata, yon tama, Dilata. Next we have Bakulo Lloyd Andre.
Sa ano po, paggawa po ng mga parts.
Okay. Sino pa? Bendanya Aaron dyan. Saan pa ginagamit?
Sir, sa mga santok, sir.
Okay, Santo.
Mga
And
santo.
so on. So those, yung mga binigay niyong examples those are some of the applications ng sheet metal. Ano? So sige, continue na natin. Mamaya ulit ako magtawag. So pag sinabi natin sheet metal, siya ay thin, flat pieces, usually by industrial process. So sheet metal is one of the fundamental forms used in metal working, and it can be cut and bent into a variety of shapes. Due to its characteristics na manipis, so madali siyang i-fold or i-bend or i-shape dun sa necessary shape na kailangan gawin. That's why when we say sheet metal, very useful yung mga bending operation, folding, shearing, kasi manipis siya. So madali siyang i-reshape doon sa desired nating output. Kagaya halimbawa, gagawa ka ng cabinet, gagawa ka ng toolbox, gagawa ka ng bubong, ng halimbawa ng body ng sasakyan, body ng tricycle, So those are some of the examples. Lumipat ba? Hindi na naman siguro. Okay, so sheet metal, syempre it varies its thicknesses. Thicknesses can vary significantly. So syempre merong latang manipis, merong katamtaman, at merong manipis, at merong makapal. So extremely thin sheets are considered foil or leaf. So yung sobrang nipis na thin sheets, ang tawag ay foil or leaf. And the pieces thicker than 6 mm, which is 0.25, are considered plate. Yung pinakamanipis na sheet metal, foil ang tawag. And then yung pinakamakapal namang sheet metal, ang tawag ay plate na. Ano mga example ng plates? Such as plate steel, a class or structural steel. Okay po? So malinaw po tayo dun sa manipis at makapal na sheet metal.
Yes, po.
Okay. So,
Yes,
masasabi nating makapal ang sheet metal kapag ka siya ay thicker than 6 mm na. Ang kapal. Okay po? Next. Lumipat ba? Hindi.
Hindi sir.
Hindi na naman.
Hindi po.
So, talagang kailangan ay ilalabas tapos ipapasok. So, sheet metal is available in flat pieces or coiled strips. The coils are formed by running a continuous sheet of metal through a roll sliter. So, sheet metal in most of the world, sheet metal thickness is consistently specified in millimeters. In US, the thickness of sheet metal is commonly specified by a traditional non-linear measure known as gauge. Okay? So, sa British or the metric system, ang ginagamit ay mm ang thickness. Pero sa US or the US customary, ang ginagamit ay gauge ang unit. So, the larger the gauge number, the thinner the metal. So, para lang din yung tools. Tanda nyo, yung nag-discuss tayo sa wrench. Diba sa wrench, ang tawag doon, ang unit ay dalawa. Yung isa, ang unit ay inches. Yung isa naman, millimeter. Okay? So, pag ang unit ay inches, ano siya? US, British.
US po. British po.
Ang inches, pag inches ang base, US.
British po.
US.
US po.
Kapag ka metric, mm. Diba? So, British. mm metric, diba? Okay? So, the larger the gauge number, the thinner the metal. Okay, magkabaligtaran siya. Ano, hindi yung mataas ang gauge number, makapalang metal. So, the larger the gauge number, the thinner the metal, and vice versa. So, ibig sabihin, the thinner the gauge, the thicker the metal. Okay pa? Commonly used steel sheet metal ranges from 30 gauge to about 7 gauge. Okay. Yagang labas-pasok, hindi magtuloy-tuloy ano. Okay po, is the presentation visible?
Yes, sir.
Okay. So, sheet metal, so sabi nga kanina, ang unit na ginagamit for USI gauge. So, gauge differs between ferrous metals and non-ferrous metals such as we have the non-ferrous, we have aluminum or copper. So, when we say copper thickness, for example, is measured in ounces. So, it representing the weight of copper contained in an area of 1 square foot. So, parts manufactured from sheet metal, we must maintain a uniform thickness for ideal result. Okay po, hindi na naman siguro yan So, sheet metal, there are many different materials that can be made into sheet. So, meron tayong aluminum, brass, copper, steel, tin, nickel, and titanium. For decorative uses, some important sheet metals include silver, gold, and platinum. Yung mga yan, mamaya sa next presentation, dun sa video recording na i-share ko sa inyo, ipapakita natin yung picture ng mga yan, yung mga aluminum brass. Ipapakita ko dun sa video recording. Kasi yung lesson 3, ay ipe-play ko sa inyo yung video recording namin ng kabilang section para naman hindi nakakapagod. Tsaka hindi naman kayo nagtatanong. So for decorative uses, we use sheet metals like silver, gold, and platinum. So platinum sheet metal is also utilized as catalyst. Next. So far, do you have questions? May tanong ba kayo?
Wala po.
Okay. So, since sheet metal is very useful, so sheet metal is used also in automobile and truck. Sabi nyo nga kanina, ginagawa siyang body, sa body ng sakyan, bubong, ano pa. So, saan? Major appliances. Okay. Airplane fuselages and wings. Tin plate for tin cans, yan sa mga dilata. Okay. Roofing for buildings and many other applications. Yung sabi nyo nga kanina, construction, ano. So sheet metal of iron and other materials with high magnetic permeability, also known as laminated steel cores, it has applications in transformers and electric machines. Okay. So baka hindi na ulit nag-play. So, historically, ang sheet metal, ginamit na siya nung panahon ng digmaan. So, the first application of sheet metal was in plate armor worn by cavalry. Yung, ano nga Tagalog yun? Sanggalang. Ano yung pang sangga, sa mga sword. Yung armor, And sheet metal continues to have many decorative uses, including in horse track. So, sheet metal workers are also known as tin bashers. Okay? Yun ang tawag sa sheet metal workers, tin bashers or tin knockers. So, a name derived from hammering a panel seams when installing tin roofs. Okay po? Nakuha? So,
Yes, sir.
anong tawag sa sheet metal workers?
Tin bashers.
Tin bashers or tin knockers. Okay po. So, next. Historically, ito yung ating history. Hand-hammered metal sheets have been used since ancient times for architectural purposes. Tama yung sabi nyo kanina, So, water-powered rolling mills replaced the manual process in the late 17th century. And then the process of flattening sheet metal sheets required large rotating iron cylinders which press metal pieces into sheets. So the metals suited for this were lead, copper, zinc, iron, and later steel. Okay, the next. Tin was often used to coat iron and steel sheets to prevent it from rusting. So ito yung kalimitan na nilalagay sa mga yero para hindi siya kalawangin. Ano? So this tin coated sheet metal was called tin plate. Okay? So sheet metals appeared in the US in 1870s, being used for single roofing, stang ornamental ceilings, and exterior facades. Tama yung sabi niyo kanina, architecture, and then sa construction, interior design, so ginamit ang sheet metal. So sheet metal ceilings were only popularly known as tin ceilings. Later, as manufacturers of the period did not use the term. Okay, next. So the popularity of both singles and ceilings encouraged widespread production. With further advances of steel sheets metal production in 1890s, the promise of being cheap, durable, easy to install, lightweight, and fireproof gave the middle class a significant appetite for sheet metal products. As you can see, gamit na gamit ang mga sheet metals. Lalo yung mga canned goods. Ano, imagine kung yung canned goods hindi siya sheet metal. Gaano kabigat. Ano? Next. I think this is the last slide for the first part. So it was not until the 1930s and World War II that metals became scarce and sheet metal industry began to collapse. So syempre, nung World War talagang magko-collapse ang kahit anumang industry kasi focus sila sa digmaan. So however, some American companies such as W.F. Norman Corporation were able to stay in business by making other products until historic preservation projects aided the revival of ornamental sheet metal. So as you can see, sheet metal evolves through the years. Ano? So napakadaming gamit ng sheet metal. So everywhere, parang halos kung saan ka tumingin, tapos may metal product. So kalimitan lagi siyang merong sheet metal components. Okay po. So that ends our first part for introduction of sheet metal. Do you have questions?
Wala po.
Wala. Okay, so we will proceed with the next topic. Okay.
Sir,
Yes po.
yung naka-record ka po ito.
Naka-record po. So, pagka naguguluhan kayo, hindi masyadong malakas yung aking audio. So, pwede nyo i-review mamaya yung recording, i-upload ko sa channel. Ano? Same with the next topics. After kasi nito, topic 2, yung topic 3 and 4 ay naka-record na, ipe-play ko na lang mamaya. And then you can review. And then mamayang hapon, yung topic 5, yun uli yung panibagong recordings. Okay, so I think kaya nating tapusin ang ating discussions for this day para next week pwede na tayong mag-start ng construction ng inyong toolbox. Okay? Sige. For the meantime, I'll be showing a video presentation muna about sheet metal.
Tapos, ito yung ating magiging illustration. Ito yung nag-illustrate niya. Like 1, 2, 3, 4. Like 4 na ganyan natin. Indicate against the natin yung average natin upward. So, upon completion of the project,
Hey y'all, we had some viewers contact us looking for some information on some basic sheet metal fab. So we're going to slow down a bit and do a little bit of a how-to. Now, if you're going to be doing any sheet metal fab to amount to anything, there's two items that you're going to want to have in the shop. And that is a sheet metal brake and a stomp shear. Now, they make these things a whole bunch of different sizes with a whole bunch of different options. We're not really going to get into a whole bunch of that, but let's go ahead and get started. Well, I grabbed us some metal out of the scrap bin so that we can do this little.
Okay, so as you can see on the video presentation, am I audible? Yung mga ginagamit dyan,
Yes,
meron
sir.
tayo sa mechanical shop at saka sa automotive shop. So, yan din yung mga gagamitin ninyo sa paggagawa nyo ng toolbox. Kaya you may carefully watch the video presentation kasi ganyan mismo yung mga equipment na gagamitin nyo next week. Okay? And then mamaya, hapon, ibibigay ko yung materials na kailangan. Pero naipasa ko na yata sa GC yung group, yung materials. And then yung group.
Hindi pa po.
Hindi pa. So,
Hindi pa
napasa
po,
ko
sir.
mamaya yung materials na kailangan bilhin. Tapos kayo ay mag-divide siguro by 5 bawat grupo. 5 bawat grupo or 6. And then, maghati-hati muna kayong 5 o 6 dun sa yero, isang buong yero. And then kung may kulang, edi the following week saka uli bumili. Okay pa? Sige. Yes, Ellen May. At saka Frank. Permission
Sir,
to speak.
napindot lang po. Sorry po.
Sige Frank, permission to speak.
Sir, asam po kung kami na po ang pipili ng mga kagrupo namin.
Pwede namang alphabetical na lang para mabilis.
Or pwede pong pilian na lang po kami.
Sir, pilian na lang po.
Pili na lang po, sir.
Ay, di
Pili.
ikaw naman ang President Frank, edi ikaw nang bahala maggrupo.
Sige po.
Tapos, bibigay ko yung materials na kailangan i-prepare. Yung yero, yun ay individual maghahati-hati. Yung mga drill bits, pwedeng hiraman na lang by group. Tapos, yung mga rivets, yun ay pwedeng by group din na para pag bumili ng isang box, hati-hati na lang yung 6. Ano? Tapos, yung bisagra, yun yung pwedeng kanya-kanya. Okay po. So, let's watch the video presentation para may idea kayo yung what is sheet metal. So, the basics of sheet metal fab lab or fabrication.
Demonstration. Now, oftentimes, whenever you're going to do some sheet metal work, you've got your go-to tools. You got tin snips, stomp shear, and say a plasma cutter. Now, all these tools have their benefits, but they have their drawbacks as well. With a plasma cutter, depending on your skill set, well, it's hard to get a nice straight cut. And also with the plasma torch, it leaves this slag. Now, with a stomp shear, it gives you
so, tutukan ko kayo kung ibig natin ay 1, 2,
Okay, itong nakikita nyo na meron tayo diyang cutter na ganyan nasa mechanical, nasa dulo, tapat ng room. Kaya lang kinabayan, mas malaki siya kaysa dyan. Okay po. So, ituturo ko naman sa inyo yung mga equipment na gagamitin nyo next week. So, ang problema lang natin next week, may mga kasabay tayong magpe-face to face kasi dapat next week tayo ay online. Kaya ang mangyayari, if ever wala tayong room next week, edi dun tayo sa labas ng automotive shop, magtitipon-tipon dun sa may tagiliran, dun sa may hagdan. Okay pa? Para po malinaw. Kasi wala tayong designated room next week kasi dapat tayo ay online. Pero nangyari, next week tayo ay face to face. And then sunod na linggo, face to face ulit tayo. Kasi tatapusin natin yung discussions today. Kasi napakahaba naman ang oras. Yes, Frank Lloyd. Frank? Mr. President.
Sir, napindot lang daw po.
Napindot lang. Pero kung may comment kayo, pwede kayo mag-comment. You can ask me. anytime, every time. Every time may clarifications, pwede kayo magtanong para mas malinaw. Ano? Okay, so during during laboratory, kahit tayo ay scheduled na online, pwede tayo mag-lab. Kasi bench work naman, pwede tayong singit doon. Okay?
That laser straight edge without all the grinding. Now that's what you're looking for. We got to cut these other ends off so we can move on. But we got our metal all squared up, and what we're going to be...
Okay, yung nasa mechanical shop is same yung purpose, kaya lang ang kinaibahan lang dito, kita nyo yung pangkat, meron doong wheel. Yung wheel ang manual na iniikot. Iniikot yung wheel. Yung may malaking gulong doon sa may mechanical. Yun yung gagamitin doon. Tuturo ko sa inyo. Okay po.
Be making is a simple box. I've got to draw a few lines on here and then trim off the corners. It's that simple. Now we're going to put this here in the jaws so that I can cut them corners off. With all the corners cut, now we can get to bending. That's real simple. We're just going to lay this line up in here in this corner, bend it around.
Okay, nakita nyo po yan, yung equipment na yan. Meron yan sa automotive shop. Ganyan po yung gagawin ninyo. Diba ang gagawin nyo next week, dadalhin yung yero, tapos magle-layout, lilinyahan. So yung pagkakat nyo dun sa malaking equipment kanina, yung cutting o yung shearing equipment, ang sunod yung bending. Yun yung gagawin nyo, bending. So, iba yung bending, iba yung cutting, iba yung folding. So yan yung gagawin nyo, ibe-bend, ipo-fold. Okay po. Yes, Delphine.
Sir, gaano po kalaki yung yero?
Ang bibiling yero, isang buo. Yung isang buong yero, tapos doon kayo magle-layout by group, tapos ikakat nyo doon sa shearing equipment na nasa mechanical shop.
Sige po, salamat po, sir.
Hati-hati kayo, parang 400 yata ang isang buo noon. Tapos hati-hati kayo. Kasi ang una nyo gagawin, dadalhin yung buong yero, tapos doon sa yero, ito-drawing nyo yung mga plano, yung mga layout, tapos ipapasok nyo dun sa shearing equipment, dun nyo ikakat. Kasi pagka ginunting yero nyo, pangit ang putol. Okay po. So sige, let's continue. May tanong? Yes. Sino yung nag-raise hands? Yes, may tanong. Sino yung nag-raise hands?
Sir, gano'n po kalaki yung toolbox na gagawin po?
Yung pinakita ko nung yung nasa may automotive shop, yung kulay green, malaki siya, malaki. Yung ibibigay ko sa inyong plano ay, ang ratio ay 1:2. Ibig sabihin, kung nakalagay sa plano ay 5, gagawin nyo ay 10.
Okay.
Magiging ratio ay 1:2. So, magbibigay ako sa inyo ng plano, tapos i-scale nyo sa into 2. 1:2 ang scale. Okay?
All right, now we're ready to bend up these little short flaps, and we can't really just stick it here in the brake, because if we did, about all we can get is about 45 degrees. So we're going to have to remove some of these teeth to get us where we need to go. Now we need to find a couple of teeth that are close to the same width as our metal. Hope you like it, and all it took was a few tools to make it.
Okay, dun sa video presentation pinakita yung process process nung cutting tsaka bending. Okay po, nakita nyo? Yan yung gagawin nyo. Kasi gagawa kayo ng toolbox. Okay? Any comment po? Okay, ito yung isa pa sheet metal project.
Best tasting na, our biggest buy, going chicken joy, yeah. Switch to Lazada. Mega brand seal.
To begin, we have a piece of metal that measures 1 foot 2.5 inches by 10 3/4 inches. I'm going to start out by laying out my number 1 operational line by creating some reference points that are a 1/2 inch away from the edge of my object. This will be a dashed line that runs almost the entire way across our sheet metal. Next, I'm going to lay out my number 2 operational line. Again, that is a 1/2 inch from the edge of our sheet metal. These will also run almost the entire way across our.
Okay, so yan na yung gagawin nyo after nyo makat yung mga pera-peraso ng ng yero. So isang buong yero, tapos ikakat nyo siya dun sa several dimension na box muna. Tapos yung mga box o rectangle shape na yero nyo, lalagyan nyo ng mga ganang dimensions. So, dyan sa video presentation, ipapakita dyan kung paano yung paggawa ng sheet metal toolbox. Okay? So, it start with layouting or dimensioning. Okay? Hindi na pinakita yung cutting ng mismong by piece. And then, afterwards, yung folding, bending, at saka yung assembling. Okay po? So, by pwede kayong mag-raise ng questions as the production or the presentation goes through. Okay?
Our workpiece. Next, I'm going to identify the corners, which will be cut out. It will be a 1/2 inch by a 1/2 inch. This will be an object line. After that, I'm going to identify my number 3 operational line, which is 2 5/8 inches from the bottom of my object. This will be a dashed line. I'm then going to measure up 7 5/8 inches, which will give me my number 4 operational line, and I get this by adding the distance from the edge of my object to my number 3 line plus the distance between my number 3 line and number 4 line. After that, we need to lay out our notches, which are located a ½ inch on either side of our number 3 and number 4 operational line. After my lines have been laid out, I'm going to identify my sequence of operation lines. After having laid out the toolbox base, I'm going to be using aviation shears and cutting out each of the 6 notch locations. Taking a look at the operational procedures, our first fold will be a single hem. This will be on our number 1 identified line. Using the box and pan brake, we will be placing the number 1 operational line in line with the edge of the finger blocks. When completed, you should have a single hem. Next, we will be doing our number 2 operational line. This will be bent to a 90-degree angle. And we will do the same procedure for the other end. After that, we're going to do our number 3 procedural line. And again, we're going to line up our line with the edges of our finger blocks. And this will go at 90 degrees also. And then that will be followed by our number 4 procedural line. This one will also be bent at 90 degrees. At this point, the base of our toolbox has been made. You want to start by double checking that your sheet metal is 5 inches wide by 4 inches tall. This is the size of each of our 2 ends. I'm going to begin by laying out my first reference point, which is 1 5/8 inches from each edge of our part. I'm then going to lay out 2 5/8 inches from the bottom as another reference point. And connect those together. My 1/8 inch chamfer will be laid out next. After laying out our toolbox ends, we will be using the squaring shear to cut each of the corners to our identified marks. It is important to line up our marks very carefully and very accurately. After our corners have been cut, we want to fit our ends into the base to see if we need further adjustments. If we take a close look at our end with it being installed, we can see that the left side is tied up against the left side of our toolbox. However, the right side, we are touching at the bottom, but we have pushed out the side of our toolbox at the top. This is an indication that our side pieces are slightly too wide to fit in here comfortably. So it is forcing that right side of our toolbox further away. We need to correct this issue before we continue. To correct this, I'm going to be creating a mark about a 1/16 of an inch on the edge of my side. I'm then going to use the squaring shear and shear off that 1/16 of an inch of material. And I'm again going to test fit that. This time it slid easily in place and did not push out the sides of my toolbox. And lastly, we're going to use a metal file to take off any burrs on the edge of the metal. After sizing our toolbox.
Okay, so panoorin yung maigi kasi yan yung mismong gagawin ninyo sa inyong toolbox. Ano? Yung procedures, tingnan nyo. Okay ba? Somehow may similarities, pero yung process, kagaya yung pagka-cut ng edge, pagka-files, yung pagda-dimensioning, halos ganyan yung gagawin dun sa toolbox. Okay po? And then, I will requiring each group na magbi-video documentation kayo sa paggagawa ng toolbox. So, and then yung isa pa, pagagawin ko rin kayo ng vlog, dun sa mga sheet metal process at saka components, kagaya ng ginawa ng IE. Okay? Kaya ang bawat group kailangan merong isang ma-assign para sa documentation, yung magbibideo. And then pipili lang kayo ng isang tawag doon, ng isang pinaka maayos na output, and then or part by part kailangan may participation bawat group para kung paano managawa yung inyong toolbox ng bawat isa. Okay po, para pinapresent ko yung video para may idea kayo kung paano nyo gagawin. Okay po, so far can you follow?
Yes, sir.
Okay po.
Yes, sir.
Malinaw naman yung yung presentation kasi kasi detailed by detailed pinapaliwanag niya kung paano niya gawin by part. And then yung mga yan, ganyan din ang gagawin niyo sa actual. Okay.
Box ends so they fit comfortably within our toolbox base. We will be spot welding the toolbox ends in place. We're going to use a series of spot welds, 2 along the shorter sides and 3 along the longer side at the base. However, prior to spot welding, we need to double check a couple things. First off, we need to make sure that when the end is installed, the sides of our toolbox are perpendicular to the base. We want a 90-degree angle in each corner. If this is not the case with your toolbox, you will need to adjust either the sides or the ends. Additionally, if your sides are bowing out, do not spot weld it. We need to make sure that the toolbox ends are tight with the sides of the base. Towards the back of my toolbox, the side is not all the way tight up against the end. Prior to spot welding, I need to make sure that this is held in place tight against the end piece. Otherwise, it will throw my measurement off for the opening of my toolbox. Prior to spot welding, I'm going to install a clamp to help hold my sheet metal in place so it won't move on me. And again, I'm double checking to make sure that the toolbox end is tight up against the side of my toolbox base. Using the spot welder, we want to make sure that the spot welder will not come in contact with the clamp, but it will be positioned correctly to give us a good spot weld.
Okay, pero dun sa ating gagawin, puro rivets lang muna tayo. Wala pa tayong application ng spot welding. Okay po?
After the first spot weld, we're going to reposition the clamp. But again, if a side needs to be pushed in, make sure that is done. On my second side, I can see that the toolbox end is tight up against the toolbox side. I'm ready to spot weld. So far, I have only done 2 spot welds, 1 on each of the sides, double checking in between spot welds to make sure that everything is lined up correctly. At this point, I should not need the clamp anymore, and I should be able to hold it in place and do the remaining spot welds.
Okay, sa atin sa halip na spot weld rivets ang gagamitin. Ano? Riveting. Okay po, can you follow?
Yes, sir.
Okay po.
Yes, po, sir.
My first end is now installed, and I can repeat the same procedure with the other end. You want to verify that you are beginning with a piece of metal that is 14.5 inches wide by 6.5 inches tall. I'm going to start by laying out my number 1 operational line, which is located a 1/2 inch away from the edge of my object. This will be a dashed line and will run on.
Yes, Aaron. Yes, Aaron.
Sir, yung video ka po, isa-send nyo po sa amin. Yan pong video.
Yes, yung recording. Sasend ko sa inyo.
Sige po, sir. Thank you po.
Almost the entire height of our object. It will be on both sides. My number 3 operational line will be a 1/2 inch down from the top. Taking a look at my number 2 operational line located furthest towards the bottom of my drawing, I'm going to identify that line, which is 2.125 inches from the bottom. My other number 2 operational line is 3.875 inches from the bottom. The lowest notch is 6.25 inches up from the bottom. Next, we need to identify 3/16 of an inch on either side of my number 2 operational lines. And then our last point of reference is 1 1/8 inches from the top of our part. This is adding together a 1/2 inch for our upper tab and 0.625 inches as our referenced measurement. Next, we need to locate our handle mount holes. To do that, I am going to create a center reference line. And base my measurement off of that center reference line. It will be 2.875 inches on either side. I then need to create a horizontal center reference line. And from here I can go a 1/2 inch on either side of that center reference line. After that, we have our latch holes. So I'm going to extend that center reference line up and base my .625 measurement off of that center reference line. After our ends have been installed, we are going to create the top so that it is contoured to those ends. We're going to start by cutting out all of our notched portions with aviation snips.
Okay, don't worry. I will also give you the copy of the plans, hard copy, para may guide kayo paano nyo gagawin siya dun sa sheet metal. Don't worry. At least, naipe-present ko sa inyo yung procedures kung anong gagawin nyo sa kabilang Lunes. Ang mahalaga maintindihan nyo yung kung paano magbasa ng plano, tapos paano execute yung plano, and then kung ano yung mga involved positions. Diyan naman sa presentation na yan, very obvious kung paano gagawin. Okay po? So far, do you have questions? Sesend ko naman tong recording. Do you have questions so far? Okay, wala. Sige.
Sir,
There will be 8.
Yes po, yes.
yung tools po na gagamitin is magdadala po meron po sa shop.
Meron sa shop, kaya lang mapupurol na. Mas advantageous kung magdadala kayo ng inyo.
Yan pong mga pang-cutting.
Yung pang-cutting, merong equipment doon, papakita ko sa inyo. Yung
Sige,
snips at shears, meron doon, kaya lang pupurol na. Kaya nga kung meron kayong shears at saka snips sa inyong bahay, o kaya may mahiraman kayo, magdala kayo, mas advantageous.
Sige, sir.
Before 10. Okay, sige, Januel de Torres. Noted.
Pieces total. And once those small pieces have been removed, we are ready to move forward with our order of operation for folding this. On the box and pan brake, we're going to begin by lining up our procedural line number 1 with the finger blocks. This will come up to a 90-degree angle. On both ends. Next, we will be bending our first number 2 procedural order line. This will be bent a slight amount. It will be under 90 degrees because we are trying to contour this to the end of our toolbox. A good indication to tell you if you are getting close to the proper angle is to take a look at the little V notch that you cut out. When each leg of the V come together, that is a close measurement for what we need this to be at. We're then going to set the cover on our toolbox and see if we're getting close to that desired angle. With this edge tight against the end, I'm still going uphill just a little bit. So I'm going to try to bend that a tad bit more, and then I'll move on to the next one. We will be able to adjust this a little bit by hand once it is folded up. After that, I'm going to flip the top around, insert it back into the box and pan brake on my other number 2 line, and fold this up at that same angle. And once again, we can double check our contour. Now there should be a small gap along the back edge of your project, and there should be a small lip along the front edge of your project. The gap along the back edge will accommodate the hinge that we will install at a later time, and the small overhang on the front edge of your project will be folded down somewhat to accommodate the latch mechanism. This will also help seal your toolbox shut. The next step is to bend the overhang on the front, and that is our last procedural order of operation line. This needs to come down so it is perpendicular to the base of the toolbox. It should be parallel to the sides of the toolbox. It will not be at a 90-degree angle to our top, but it will be a 90-degree angle to our cut mark. So we will line up that third and final operation line. And bend that into position. And another quick test. And I think we're looking pretty good. Our toolbox will have a hinge running the entire length for connecting the cover to the base and allowing us to open and close it. The hinge consists of 2 pieces of metal with fingers and a pin running through the fingers. If we take a look at the back of the hinge, you can see what almost appears to be a line going down the length of the hinge at the base of each of the fingers. Each of these lines will be our reference lines for installing the hinge on our project. It is very important to recognize and identify these reference lines prior to installing it on your project. The distance between these lines will be the reveal of our hinge on the back portion of our project. The hinge will be installed along the back edge of our project. This is the edge that is opposite of that single hem that we put on the base. The single hem side is the front of our project. We want to focus on the back edge. The hinge will also be going on the inside of our project, not the outside. To lay out the hinge, again, I'm going to be basing my hinge location off of that reference line at the base of the fingers of each of those pieces of the hinge. If your hinge is sticking too far forward, you're going to run into problems with your toolbox not closing properly. If you put the hinge too far back, your toolbox isn't going to be able to open or close because it cannot pivot on that hinge pin. With the hinge positioned correctly, I'm going to be placing 2 clamps along the length of the hinge to help hold it in place.
Pero yung nasa plano na gagamitin nating hinge ay yung parang sa pintuan lang na hinge. Hindi yung ganyang straight hinge. Pero pwede rin naman ganyan ang gawin nyo. Kaya lang i-adjust nyo yung plano. Okay po. Whichever pwedeng gamitin. Okay? Whichever pwedeng gamitin dun sa hinge. Okay? Okay po. So far, do you have question?
None.
Walang tanong?
Wala po. Wala po.
Wala po.
Sige. Let's continue.
I'm then going to double check and verify that that reference line is running along the edge of the back of my toolbox. If everything looks good and everything is lined up perfectly, I'm going to spot weld the hinge in 2 spots, one on each end of the toolbox. And this may require 2 people to help hold it in place. After spot welding, you can remove the clamps. And spot weld it in 3 additional locations. After spot welding, you will want to let the hinge cool for a few minutes before attempting to set up the cover for installation. After our spot welds have cooled, we are ready to set up for installation of the cover. When laying this out, we want the same amount of reveal on the hinge that we had when we installed it on the base. Additionally, you want to make sure that when it is closed, the cover fully is seated on the toolbox. You don't want to spot weld it clear over here. That cover needs to be centered around the toolbox. Following similar procedures as the base, we're going to clamp that in place. Ensuring that our hinge is lined up with the same amount of reveal. Now, before continuing, double check to make sure that the cover is centered on the base. Looking at the right side of my toolbox, I can see that my base is sitting slightly to the left of my cover, which could be okay because we want those little tabs to close around the outside of the base. However, when looking at the left side of my toolbox, I can clearly see that the left end of the toolbox is sitting outside of the cover where it's going to close. this lid is going to close and there will be a gap on the left side of my toolbox. I need to adjust the cover and split the difference between these so that there will not be a gap in that toolbox cover. It will close on top of and on the outside of both of those end pieces. After that, we want to double check the reveal of our hinge in relation to our cover. My cover on this end of my toolbox is sitting just a little bit too far away from the hinge. I can tell that because the pin of the hinge is a pretty far distance from the edge of my cover. I need to take the edge of my cover and slide it inward toward the hinge pin. After laying out everything perfectly and double checking and triple checking the spacing of the hinge and the cover, and that the cover will close and it will go around the toolbox, I'm ready to spot weld my hinge following the same procedures. 2 spot welds on the ends, remove the clamps, 3 additional spot welds down the length. And after that, we can check to make sure that everything looks good. We will be using pop rivets to install the corners onto our project. Taking a look at the corner, we're going to set the first one in place. And we're going to use a marker, and we're going to mark the hole locations. We're going to position the toolbox so we are always drilling down. This is a 2-person job. One person will need to secure one end of the toolbox away from where the other person is drilling. The other person will be drilling with 2 hands on the drill. Because remember, if you have 2 hands on the drill, you can't drill through your hand. Drilling slowly with a light amount of pressure, we're going to drill each of these holes. Then we're going to rotate the toolbox again so we are always drilling down, and continue with the same procedure until all of the holes are drilled. After all of the holes are drilled, we can use a pop riveting gun to install our pop rivets. Make sure you are maintaining firm downward pressure so that pop rivet will be tight up against the project. If you have a corner that does not sit very flat, it wobbles around, perhaps because we have a real sharp point here, you can take a metal file and slowly bring down that corner. Now that corner sits tightly on there. We have previously laid out the handle, which actually ends up being on the inside of our toolbox. We're going to lay that out again, but on the outside. However, this time when we lay it out, we cannot use that 7 1/4 inch measurement to find our center point because we've already folded down the end 1/2 inch. So if we take 7 1/4 minus a 1/2 inch, that will give us 6 3/4. That is the measurement that we need to find our center point. Before drilling my holes, I'm going to lay out my handle pieces just to make sure that everything is lined up correctly and that it looks like it's centered and it looks like everything's going to work. If you do notice a problem, now is the time.
Pero yung gagamitin nating handle sa inyong toolbox ay improvise yung handlebar. Ano? Gagawa kayo ng improvise handlebar. Okay po. Can you follow?
Yes, sir.
Yes, sir.
Time to fix it. After that, we can drill our holes. Again, this is a two-person job. One person needs to be holding the toolbox securely away from the drilling location, and the other person needs to be drilling with two hands on the drill at a slow pace with light pressure. Now, if you install both of the ends, the handle will not fit in. You won't be able to get the handle in there. So we need to install one end, place the handle in position, and then install the other end. And this will also be done with pop rivets. The latching mechanism is composed of two different pieces. We have a catch and we have the actual latch. The catch is designed so the latch will hook around it and catch onto the lip. This is important because we need to install this in the right orientation on our toolbox. We need to make sure that the hook end is facing up so that latch will hook on. Inside our toolbox, we have actually already laid out the hole locations for our catch. Using a hole punch, we will create the holes that will take the pop rivets. And a couple pop rivets will help us secure that. But make sure that you are installing it with the hook end up. To lay out the bottom portion of our latching mechanism, we're going to hook that onto our top portion. And if we depress the top, we can see that the top has some give. That give will affect the location that our bottom portion of our locking mechanism will be positioned at. We want to maintain downward pressure, and with that downward pressure, we're going to mark our hole location. This is typically located less than a ½ inch from the bottom of our toolbox. Using that bottom hole location, I can identify my top hole location. And we can drill those holes. And use a couple pop rivets to install that in place.
After that, we can test its functionality.
Okay po, so yun po yung simple presentation kung paano gumawa ng toolbox. Ang parts lang niya doon ay yung body, side cover at saka top cover. Wala siyang organizer at saka wala siyang procedure dun sa paggawa ng handle. Pero yung gagawin yung toolbox, may side cover, may top cover, may body at saka may handle na gagawin at saka may organizer. 5 ang gagawin. So somehow yun yung operations, kaya lang instead ng spot welding ang gagawin, ang gagamitin nyo ay puro rivets. Okay po? Questions? Hello, questions?
Wala po.
Wala.
Wala po.
So I will post the recording kasi siya ay nire-record